Hey everyone, again it's Wandile here, the leader and the instructor of Manikwe School, and today we're gonna be doing exercise 5.13. It's a pretty straightforward problem, so I don't see the point of doing, or rather giving, more than one solutions. Okay, so without any rambling, let's get on to it. So this is the problem here. Let me try to zoom in first. Oh, there we go. Again, with this machine it can be slow sometimes. Okay folks, it seems like out of reader is kind of giving me hard time, so what I decided to do is to use reader instead. So this is this is the problem on hand, by the way. Okay, so we gotta find the largest n such that n cubed is less than 12,000, and they were specific. So what they said is we gotta use a while loop to find the largest integer n such that n cubed is less than 12,000. Okay, so first and foremost, what we want to do is to create a variable to hold that n value, right? Of course, what we can do is we can simply initiate this to a number like 1. But that logically doesn't make sense, because we all know that 1 cubed is 1, and of course 2 won't do it as well. Likewise for 3, because 3 cubed is actually 27. So it will make more sense if we try a number like 10, for instance, because that will immediately tell us that it will start from 1,000, because 10 cubed is 1,000. Okay, so let's try that. Of course, you might try a different number above 10, but what I will simply do for simplicity, I'll use 10. So what I want to do is to use the method.pow method, right? Okay, there we go. This machine of mine can be slow. I'm gonna ask you folks to bear with me. Okay, so we'll simply put n, and then I'll put 3 here. So we're continuing while method.pow is less than, while this computed value is less than 12,000, right? Okay, if that is the case, what I'll simply do, I'll simply go n plus plus. N, I will simply increment my n. That should be pretty much it for this system.out.print. Oh, just before I keep going, you folks, I just want you to know I'm taking this video outdoors, even though I'm at home, so people might pass by, you might hear them greeting me, so I'm gonna ask you to please bear with me there. Okay, anyway, let's keep going. We display our n, so let's see what we get. Let's hit the run button. There is it right there. Let's see what we get. Boom, 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 boom. Oops. It seems like I made a mistake somewhere, somehow. The value of n is 11. Obviously, that doesn't make sense. $11 cubed. Why am I having hard time displaying that? Why am I having hard time believing that is 11 cubed? That value there. Okay, let's see. Let's try to start from 5. and see if we're gonna get the same answer. And if we do, immediately we'll know that our algorithm works perfectly. It seems like it does, folks. That should be it for this tutorial, you guys. I know my approach might have been you might make an argument that I've cheated, maybe because I know 10 cubed. You might make an argument that things would have been hard for me if I had a different number, something huge. Something greater than 12,000. And I would understand. But using a number, starting from a number greater than 1 on this problem is actually more faster than starting from 1. Anyways, folks, that should be it for this tutorial. See you on the next one. Cheers, I'm gone.